So we're going to get started talking about what's new with Firebase for Professionals in 2019. Again, one last chance. If it's not the talk you intended to come to, please leave. And if it's not the talk you intended to come to, but you want to stay, you're welcome to stay. For those of you who haven't met me or haven't seen me at previous year's DevFest, my name is Abe Haskins. I'm a developer programs engineer on the Firebase team, which is Google's way of saying I help people use Firebase in a technical way. So I'm guessing since you came to a talk called Firebase for Pros, you have probably used Firebase to some extent. Is that correct? Has anyone not used Firebase? Okay, that's fine. I will briefly, okay, two people. I'll briefly cover what Firebase is, and then we'll dive into what's new in 2019 for being a badass while using Firebase. Firebase is a platform made by Google. If you're familiar with Google Cloud, as I would really hope you all are, Google Cloud is an infrastructure as a service product. So if you want VMs and you want compute and you want raw storage, you can get that on Google Cloud. But if you want other things like the easiest possible way to run code in the cloud, or you just want your user to be able to sign in with Google or upload a profile picture, all of these things are common use cases that everyone has to do. So Firebase is a platform as a service, and it's not like App Engine, which is also a platform as a service, but much more of a server-side platform. Firebase tries to be a very easy-to-use platform that you connect to directly from your client. So you include our JavaScript SDK or our Swift SDK and point it at our servers, and we take care of everything from that. You don't have an intermediary Node server. You don't have an intermediary Java server that's like talking to the database unless you want to. So we just simplify it. We make it easy for you to build stuff that everyone's already built. And we try to do that as easily as possible. Like anything though, as you grow and as your application becomes more complex, sometimes Firebase stops being the right fit for you. You need to move off onto Google Cloud where you need full infrastructure as a service tools. Sometimes Firebase is a perfectly reasonable tool, but because you didn't prepare your code base or your ideologies about Firebase going in, you kind of find yourself in a bit of a pickle. Maybe things aren't scaling how you'd hope, or things aren't working exactly how you'd expect. So, did any of you come to my talk last year at this same event? Yes? Fantastic, because this is basically the same talk. But it's got a bunch of new stuff because in the last year, things have changed. Google has released a bunch of cool new stuff. So I'm just going to go through, talk about the same stuff I talked about last year, which is how we build good things on Firebase, how we act professional when using Firebase. And then as I go along, I'll say, but wait, we can do that in a different way now. We can do something better because 2019 has brought some new stuff for us. So first, let's talk about what's the same, what hasn't changed since last year when I gave the same talk. And the same thing is still true. The goal of any platform, of any software, of anything when you're building is you want to be able to act confidently. You want to be able to walk away from your code and let it sit in production or do whatever it's doing and feel confident that it's going to keep doing that you want to know what to expect. This is obvious, but it actually manifests itself in a bunch of interesting ways. Confidence isn't just about stability of code. It's about confidence in making changes to your code. It's about confidence that when you bring in new engineers, they'll still be able to maintain that code. Confidence plays into everything about serverless technology, everything about platforms as a service, and it even plays into being confident in Google. How do you feel comfortable knowing that you're buying into a product that Google might shut down one day? I don't think we would. I personally, having worked on Firebase for 6 years and watched it get acquired and grow and everything, I would never guess that we'd shut it down. But this is all confidence. Every part of this is about building confidently. So as we go through, some of the stuff we're going to talk about is going to be just like code stuff. I'm just going to be like, you should really do this. And that's great. But some of it's going to be more high level, like you should be thinking about this as you're building on Firebase. Here's how to prevent getting a bill you don't expect. Here's how to prevent having new engineers get confused. We're going to cover a lot of different stuff. So overall, the things I really think are important that a lot of people get wrong are these 6 things. So this is clean and strong code, having a systematic, deeply ingrained idea about testing and how that interacts with cloud services, dealing with instant deployments, dealing with rollbacks when things inevitably go wrong, dealing with different configurations, different staging environments, dealing with monitoring. How do we know what's going on in our application? How do we feel confident that if something goes wrong, we will hear about it? And then the last one is having predictable pricing, saying, all right, if this product grows 10x this year, is it going to cost me the same? Is it going to cost me more? What's a fixed cost? What isn't? And having a good idea so you can say, all right, I feel confident that what I'm building today is going to continue to be the right business decision for us a year down the road, 2 years down the road, whatever. So we're going to dive into each of these topics, but before we do that, I want to tell you about a very handy acronym I made to remember to do clean code testing, deployment, rollback, config environments, monitor pricing, which is CTDR-CEMP, or CTDR-CEMP, as I call it. This acronym has yet to catch on, even though I've been giving this talk for 18 months or so. No one's ever like, yo, I use the CTDR-CEMP method. So I might change it. But for now, it's still CTDR-CEMP. So if you just remember CTDR-CEMP, you'll be green. So let's start with the first letter. Code. We all write code, pretty much. If you don't write code, I'm sure you're aware of the concept of code. Otherwise, you wouldn't be at a DevFest. The first thing, when we're building something new, we want to be able to iterate quickly, right? We want to be able to build code that we can make changes to, where we can ship features and we can roll with it and then build stuff. This is kind of like the fundamental thing about coding, and it's the part that I think all of us really enjoy, is making something and seeing it come to life. So here's an example of a JavaScript function that you could write. Like I'm running through, I'm thinking, all right, I put some data in my Firebase database where there's a map of users and it says what their role are. And then if I want to just check if they're an admin user, I go and I read this specific value in the database, and if it's true, then we're all good. This is an example of a code snippet. This is Firebase specific, but you'll kind of see throughout all of this, these are general ideas about how I think we should think about these problems. They're not really Firebase specific. The code will often be, but it doesn't really matter that much. But anyway, my point with showing you this is that this function is really broken. There's a lot of issues with this function. And at first glance, having written Firebase code since before the original Firebase database was in beta, I would still struggle to read this and immediately see these issues. And even if you look at this and you're like, I can see why this doesn't make any sense, I guarantee to you, an earlier engineer on your team, someone less experienced, someone who doesn't come from a JavaScript background, someone who doesn't have that breadth of knowledge you have, they're not going to be able to. So one of my first initial pitches is that we want to solve all these issues. Whoops, that's the wrong laptop. The first issue, there you go. You may not be able to read that. But one thing is that Firebase database is a method. It's not a field, so you have to call that. You have to invoke database for this to work. So that's easy to miss. That's a missing set of parentheses. What else? What else is wrong there? I can't really see my slides. There you go. That string val, that's supposed to be the word value spelled out. You know, pretty close. 2 letters off, but easy mistake to make. So all of these issues we see here are like typos, right? They're small mistakes that come up, and you say, well, that's fine. I would have ran it. I would have ran the test. It would have errored out. I would have fixed it. And that's true if you were doing a very rigorous test-driven development, or the more realistic situation is that you would run the code, you'd click a button or two, it would break, and now instead of wasting preferably no time at all, you've wasted 30 seconds or 45 seconds. And if you're a worse engineer or someone less experienced, you could waste minutes, or you could waste quite a long time. And this gets really expensive, and it hurts that iteration. So one of my biggest overall recommendations when building with Firebase is to use TypeScript. Please. How many people have strong feelings about TypeScript? How many people with those strong feelings like TypeScript? Okay, everyone. That's fantastic. Nobody hates TypeScript here. And those of you who don't have strong feelings soon will, because you'll have my feelings after I explain them to you, because you're smart and you'll believe me. So TypeScript is, for those of you who aren't familiar, just JavaScript with additional knowledge on top of it about types and things like that. So everything we talked about right here, these are all type issues, all right? So the first thing that we're missing a return at the beginning of the function, that would be fixed because if our function had a type declaration, if it said, hey, I'm expecting this to return a Boolean, or I'm expecting it to say, is it, a true or false type thing, then it would catch that. It would say you're not returning anything. TypeScript would also catch that database.ref is not valid because it knows that database is a function that needs to be invoked in order for .ref to exist. And it would also catch that val is not the right string because TypeScript is smart enough to understand in situations where strings can only be a couple of things like value, child added, child removed, that val is not one of those things. So these three issues, which are all trivial but all add up, 45 seconds a piece becomes a couple minutes a piece. Do that every day for a couple years, you waste a lot of time. So TypeScript just really, really fixes a bunch of these issues. And there's big advantages to TypeScript. And I'll touch on this briefly. But TypeScript just as a tool to help you iterate faster, help you feel more confident when you're typing code is really, really good. So here's the same function, JavaScript, really not good. Not a language I'd recommend any of us ever use. Rewritten in TypeScript. And if you're a JavaScript engineer who is reasonably up to date on the times, not writing ES5 anymore, you probably look at this and say this doesn't look any different than modern JavaScript. And it absolutely doesn't. We flipped the function to be an async function. We returned snapshot.val. There isn't anything actually TypeScript specific here. This is just JavaScript. And this is one of the beauties about writing TypeScript, is if you're in a situation where you're writing JavaScript code and consuming values returned and things like that, TypeScript does a really good job of inferring what you want. So if you went and used is user privileged somewhere else, it would know that it's expected to return a value if you're using it as a function that returns a value. So we can do things like not write anything. We're not saying this returns anything. We're not doing anything special that's not normal JavaScript, but we're already gaining more confidence. And every one of those typos we talked about, it would catch if we were using it in another location where it expected a return, where it expected this or that. So even though this just looks like JavaScript, running it through the TypeScript compiler helps. This is also a big thing about TypeScript, is that because it understands your code better, it knows what's a function, it knows what's a value, it knows what types they are, we get like really good autocompletion. And if you're using, certain editors, you might be like, oh, my JavaScript autocompletion is like pretty good. And the answer is it's either not, you're either wrong, or under the hood, the libraries are using TypeScript and you're getting some of the benefits of either TypeScript or some potentially another type system like Flow by association. So sometimes editors are smart enough that you import a library that says, oh, I'll use the typing definitions because they're so good. And that's when you get this good autocompletion. So in here, I'm using a nice editor, and it really understands these different methods. It's saying, here's exactly what is on this object, here's what fields that has, here's what it takes, here's what it returns. And that gives us the ability to write code more confidently. A third part, and this will be the last part about TypeScript. If you don't care about TypeScript, don't worry, we'll get out of it in a second. Excuse me. The third part about TypeScript that I really like is that it can be used as a general purpose bar for determining if a third-party library is good. Obviously, we have issues in the JavaScript community with dependencies. People really love libraries, and they really love just making a library and throwing it out on GitHub, and then ignoring it for 6 years while it becomes like one of the most dependent on node repos in the world. And then we have all these other issues. So TypeScript is a relatively recent technology. It's 4 or 5 years old, something like that. And by looking at dependencies through the lens of, does this support TypeScript, is actually really valuable. Because not only are we getting a general indicator of saying, all right, has this person updated this library since 2012? Which, in the node world, sometimes they don't. But it also gives us the advantage of saying, is this library author willing to make a contract with me about what this library looks like? And so by that I mean, if you look at a library and JavaScript can expose anything, it's really crazy. You could have an object, your module could expose a string, and that string could have a method on it, and it's wild, right? But by having TypeScript and shipping types in their node module, they're saying, I'm willing to guarantee you that between releases, this is going to be correct. And I'm going to have these methods. I'm going to have these fields. And if something changes where I don't, or the signature changes, or something goes wrong in my library that's no longer matching that API we expect, now that's a compiler error. It is not a runtime error. So we catch it when we're doing the compilation step, not down the road when some user happens to hit that API or that some method on that node module down the road. So it lets us catch that earlier. It doesn't prevent us from maintainers who ignore their modules and don't update things and let their typings fall out of date and things like that. But it's generally a way to keep an eye on things we depend on. So real quick example of this, if I searched for a tool that let me put colors in my terminal from my node script, and I just search for the word colors on NPM, obviously I get 3,602 packages because that's how many there are. And I looked at this and I thought to myself, okie dokie, 3,600 of those, let's just ignore them. Somehow we knew already those 3,600 weren't the ones we want. We get 2 back. And these 2 are colors and chalk. Now if I look at this and I think, all right, colors 1.1.2, that's a decent version number. Chalk 2.3.0, also a decent version number. And then we go and we looked at the code for these or the usage stats, we'd see, well, Colors has about 2.3 million downloads a day. Chalk has like 700,000 downloads a day. Maybe I should go with Colors. But under the hood, there's a lot more to pull out of these. So if we glance at the package JSON for the Colors module, you can look through here and you can find that there's no reference to TypeScript. The 2 things we're looking for are 3 things: the word type at all, the word TypeScript, or a TS or a DTS file reference. Those are basically the things that will exist in this package JSON if this developer is using TypeScript or shipping type definitions with their code. So by seeing that this developer doesn't do that, they don't make me any guarantee about what this library looks like, that gives me a pretty good feeling that this library is probably pretty old. And if you knew the whole context and 6 years of node history, you'd know that Colors is a library that extends the string prototype, and that is not in fashion anymore, so it's generally not recommended. And today, Chalk, which if we look at it and we can see has this index.dts file listed. This one is the one that is generally preferred. Now, this doesn't solve every problem, but it sure helps. It gives us some indication that these people care and are keeping their things up to date. It's a more modern library and still has the heavy usage. It's not like people aren't relying on Chalk. It's just not as popular. So as we go through these chunks, a bunch of these are going to have these little share links at the end. I know they're still pretty long, sadly, but you don't have to worry about taking pictures or anything, because at the end there'll be one slide that has all the links I talked about. So just wait for that, and you'll be able to go read about all these things I talked about. All right, testing with T and suitor. How many people write tests? Okay, that's like a solid 65%. I like it. So testing has one fundamental issue that 35% of the people in this room don't get right, which is that we really need to write them. Right? Testing is a big issue, and it's something I avoided personally for a large part of my development career. I was many years into writing code before I wrote many tests. So the first thing to test is you just have to write some. Because the best way to get in the habit of testing things is to get over the burden of not testing them, right? We need to get used to the tools. We need to get used to the methodology that the way we test things is not by running them in the browser and clicking on them, but by writing end-to-end tests, by writing things that allow us to instantly test 100 use cases instead of manually testing one and hoping it doesn't break the other 99. The testing section is pretty short. It's mostly just me telling you, please write some tests. I'm not going to get into different methodologies and different ideas because I don't really care. I care more that you get comfortable writing tests and working on them. The one tip I really do have about this is that you need to make it easy on yourself to write code, right? Like I said, we need to lower the barrier by using the tools to make it easy to write tests and get in that cycle. But that's really, really hard on some projects. Big existing projects that weren't designed to have tests integrated into them are very hard to instrument with tests. It's very expensive, and you end up doing a lot of things with spies and complex mocks where you're trying to like replace core parts to figure out what part you're testing. So I really recommend writing your code from the beginning in a modular way that you can go in and cut things out. So a quick Firebase example with this. Here's a cloud function. If you're not familiar with cloud functions, these are the way in Firebase that you can go and have some code react to an event. So for example, a new user signs up and you want to send them you want to sign them up to your mailing list. You can do that in a cloud function. And that ships up and we run it on our servers and we scale it for you and do all that. You just write like 10 lines of Node.js, preferably in Python or in TypeScript, and then we take care of the rest. So this is a snippet. It doesn't really matter what it does. The gist is that it's sending a push notification when you write a message into a chat room. Okay. This is generally how these functions are written. We have this cruft up at the top, which is all the Firebase functions SDK stuff, functions, Firestore, document, path, on create, do this event. And then we have our logic, and our logic here is a mix of the code to load from the room and figure out who needs to get sent a push notification and the actual payload that gets sent to the push notification API. But it's long, it goes off the page, and it doesn't really matter. A better way to write this, specifically in Cloud Functions, is to break it up a little bit. So here we've split this, and instead of exporting a single top-level function called send to room, we are now exporting this object called FCM, which is for Firebase Cloud Messaging, and we're saying everything related to push notifications, everything related to Firebase Cloud Messaging, we're now going to bundle into this object, and we're going to expose that. Now when we deploy this, Firebase is smart enough to say, all right, you exposed an object that has functions on it, and it automatically names them in a nice hierarchical way so you can see that you're exposing multiple related functions. Then I broke out all the FCM handling code to a different location. That's now in a function called manual FCM handler, which is off screen. It's in send to room, which is now off screen. But the important part here is I've broken it up into two types of functions. I broke it up into a manual function, which is an HTTPS trigger. So that's one we can curl, or we can open in the browser, or we could potentially write a test against if you had something environmentally specific where you felt like that was a useful integration test. And then we have automatic. And the automatic one is the one from Firestore. Now it's hard to test a Firestore function invocation because in general, you have to deploy to the cloud, you have to write to Firestore, and then you have to check and see what happened. That's not a flow that fits very well with testing. It's hard to fix. You're like, how do I watch and know that the right invocation came through and everything? So we break out send to room. That's now a function. We can test it on its own. We can import it somewhere else, completely devoid of the functions SDK itself. We can manually invoke it and manually test it by hitting the HTTPS endpoint. Then we can do the Firestore function, which is the actual production invocation, automatically when people write to Firestore. But because we know the Firestore specific logic is just these two lines, just the data.data and event.params, we know there's very, very little that could go wrong in the Firestore version versus the manual version versus the send to room invocation in a test. So breaking things up like this helps a lot. It just gives you more touch points to the same logic, so we have more flexibility in terms of going in and testing stuff. And we don't have to stub out the functions SDK. We don't have to do anything specific. We're just organizing our code a little bit differently, and we're getting a lot more testability out of it. Yeah, so recap, things I changed. Top-level namespace gets exported. The functions are now also exposed as HTTPS. The specific logic gets handled for that type of invocation, and then the actual business logic is in a separate function. One of the last things about testing is that once you write your tests and continue to write tests as development goes on, you need to be in the habit of running your tests. This is surprisingly common that people will go ahead and they will work on some tests, or you have one team member who is dedicated to writing tests and 4 who aren't. And the one is like, hey, everybody, run your tests before you commit. Make sure they're all passing, and then they don't. So general tips here. There are lots of cool tools that let you enforce testing. So here's one for Firebase. you can have a functions pre-deploy hook that just says, if you try to deploy your Firebase functions, we have to run your tests first, and they have to pass, and then you'll allow it to be deployed into the actual cloud project. The same idea exists in other tooling. Git, for example, has a pre-commit hook that says you can't commit code unless it has passed these tests. That's a more aggressive option, but still good. We ship a template in Firebase that says you cannot have uncommitted code deployed. So if you wanted to, for example, say, all right, you can ship to production when you feel it, you're comfortable, but you can't do it if that code's not checked in. It has to be visible to the rest of the team before you can ship it up. You can do that. So there's lots of options here that all kind of get to the same point. That's getting everyone on the same page by adding like a line or two of extra configuration data. It kind of helps get in the process, right? We're making it easier. We're making it simpler for people to contribute tests. This rolls into my next topic, which is the doctor part, which is make sure to eat lots of vegetables because good coders need fiber. No, this is deployment and rollback. How many people are familiar with some sort of continuous integration, continuous deployment type tool? All right, pretty much everyone. So I don't have to sell you on this too hard, but I'll talk a little bit about it. Deployment and rollback gives us the ability to be confident, again, see confidence keeps coming back, that if something goes wrong, we're not going to be totally fucked. If something somehow makes it through our tests, which I'm sure are comprehensive, and it gets out in the wild, it gets through our staging environment, and it's out there, and then we realize we did something horrible, we need to design from the beginning a system so that if that happens, we can immediately fix it. So this comes in two parts. One is the actual active deployment, making sure deployment is easy, making sure the bust factor on deployment is low, so that no specific person needs to be called in the case of a bad push to production. The second part is making sure that the tooling makes it easy to roll back, so that if something goes wrong, we have some agreed upon system, which is how we go back to what we were doing before. So yeah, you're all familiar with these tools, CI/CD. This is one of the parts that's changed since last year. All these tools are great: Travis, Circle, Semaphore, Jenkins, pipelines. They all provide similar things here, right? Like we're automating the actual deployment step so that we have a trail, we have a history, we have the ability to go back. One of the interesting things we launched over this year was Google Cloud Build, also known as Container Builder, depending on who you ask. And this is our CI/CD tool that integrates with Google Cloud. So everything I'm talking about here, my example is about Semaphore because that's what I was using before we launched this. But everything works with Cloud Build as well. You can build up whatever you want inside Docker containers and ship them out. So here's a little project of mine, jpeg.cool. It's a great website. If you go to jpeg.cool/anything, it searches the internet and returns an image of it. It's a very simple website, and I have to update it about once every 350 days. So once in a while, I have to go edit it. And inevitably, by the time I go update it, I have forgotten how to deploy it. I've forgotten every interesting detail about the code base. But, I learned that, I had to block some bad word or something, right? So I use a continuous deployment pipeline for this. Every time I commit to the Git repo, it automatically builds up my Go code, rolls it up, ships it up in a Cloud function, sends it on its way. But because I only edit this code once in a while, the likelihood that I do something that breaks it is very high. I also don't have very good test coverage on this project, and it's not that important, so it's not a big deal. But all of these things come together to a situation where the likelihood of a bad deploy is like 75%. So I ship these out. I have this little build pipeline. So this is just everything that gets ran in order to actually ship up a version of this project. And then, as I go through and I commit, I can make a good commit or a bad commit. It goes, it deploys up. Now, what's really interesting here is that every version, every git commit that's ever been shipped up is now going to have this little button on the side that says deploy manually. And this is that savior button, right? Where now, it's not just a bunch of commits I have. I don't have to go and say, all right, I know the commit from last year was good. How the hell do I roll back my local repo without ignoring my changes, or without destroying my changes. I would roll it back, and then I could rerun the command line tool to recommit it. It's like, no, we don't deal with any of that. We hit that deploy manually button. It says, oh, okay, you just want to do the exact same thing on this old commit. Sure, we'll do it. A few seconds later, the old version's back in production. And this is the type of thing, it gets much, much harder as we scale. Ideally, any given bundle, any given release of something should be atomic. So it should have a completely self-contained bundle that you can put on the internet, and then if it goes wrong, you can take it back out. It doesn't work like that in real life. A great example of this is like a database schema changing. It's very, very unlikely that you would have a good system to change a database schema and ship a new version that relies on that, and then you could somehow roll it back on the same database without losing customer information. So it gets blurry. So I think one of the more important things here is that this isn't just purely a technical solution, it's also like a documentation and business solution about how do we write these rules, how do we have systems in place that people are aware of to say, all right, here are the type of changes you definitely can't roll back, here are the type that you can, and getting those processes in place, just so you have a mature system that says, all right, here's how we handle these issues. If you're interested specifically in the Semaphore example, it'll be on that link. The link will be again at the end. Next, C and E, configuration and environments. When I talk about an atomic bundle of a project, and I talk about the ability to take that bundle with all your configuration, all your security, all of your code, all of your everything, and deploy it to the internet, it's not just one version of the internet that I'm talking about, right? We realistically don't often deploy just to one place. We deploy to production, but we also deploy to a staging environment. Depending on the complexity, you might deploy to a development environment. And these are things that ideally would be very simple. We'd be able to say, all right, just ship the same code to the staging server. That should be fine. Realistically, that tends not to be how this works. We have big script files that say, all right, am I in production? Ship it up with these flags to this place, tell it to connect to this database. If I'm in this environment, do this. So they end up being these really complicated, really ugly flows. A lot of times, the production deployment is the default because it's what people thought of first, and then the staging environment is second with some optional flag, which means a lot of times people will deploy to production when they wanted to go to staging because they forgot the flag. There's a lot of potential issues here. So some of the ideas Firebase has around how to solve this is that our core idea is that we want to detach our code from configuration, because most of the time the part that's causing issues between environments is configuration data. It's what database am I talking to? Am I encrypting passwords? Am I doing this? Am I doing that? For in which server, in which region? Am I rolling it out to 20 servers or just one? Whatever, right? These are all just configuration values. So Firebase does this really cool thing. If you're building a web app, a PWA, anything like that with Firebase, you can import one of these magical files. It's the one on the bottom there, __init, or _Firebase/init.js. And what that is all the code required to connect this web page to Firebase. So it's your project ID, your FCM sender ID, your cloud storage bucket, everything like that. And this file doesn't exist in your project. It's never checked in, so you have no chance of leaking these credentials if they're to a hidden project or something like that. These credentials exist only as served up by the environment. So Firebase hosting magically connects this file back to the underlying project. So that means if I'm building an app and I have a production project and a staging project, when I ship this up, there's no magic flag. There's nothing that says use this version's config. It just says, oh, when I'm in that environment, I'm going to look, and that environment has the minimal amount of code to tell me where I am, and I will do the appropriate thing from there. So this concept, I think, is really useful, even outside of Firebase. I've recommended people do something like this for their own environments, like have that hoisting over, code in your server that is actually basically recreating this concept where the initialization comes from some long-living thing in that environment. Because it's just so much smoother, It makes your code simpler, it makes it cleaner, you're not checking in config data, lets you change it very, very easily. We see the same idea when we get into the actual code for our server-side code. So if you're looking at a cloud function, here's a cloud function that sends some email. And you can see, normally we might put in a hard-coded client ID, we might put in an access token, but that's bad. We don't want to check that into Git. We don't want the wrong one going into the wrong environment. So here we use an environmental config that Firebase provides, which is at functions.config, and that just pulls this in automatically, again, from the environment. From the same service that tells us you're connecting to this Firebase, this is arbitrary key value pairs that come from the environment. So when I deploy to production, use the production credentials. When I deploy to staging, don't use my real Stripe credential. Like, it's just that simple. So these ideas about detaching any configuration from your code, like you can still, if you need to, do switches and say, all right, if I'm in production, show the bright yellow favicon, and if I'm in, or if I'm in staging, show the bright yellow favicon. If I'm in production, show the normal one, whatever. And that stuff doesn't really get cleaned up. But this reduces the chance of leaking credentials, and it makes it simpler. And once you get really fancy, you can put security around these credentials in ways that it's hard to if you're checking them in, right? You could have a single administrator who actually has access to modifying these credentials, keeping them up to date, and you're not relying on whatever's in the Git repo that anyone can edit. One last thing, again, this is pretty Firebase specific, is the idea of multiple environments, multiple projects. This is also another thing that's changed about Firebase. Historically, we've always said, if you want to have a staging version of your Firebase project and a production version, have multiple projects. This is generally recommended because the likelihood of you making a mistake that crosses the boundaries that you put for yourself is fairly high. It's okay if you delete everything in staging, please don't delete everything in prod, right? So this has been our safety net rule. But recently we've been making a lot of changes that make it more practical to run multiple environments of the same project in the same Firebase project. So what I mean by that is we've added things, there's nothing else on the slide. So we've added a couple of things. Right now, if you're familiar with Firebase's real-time database, you may be familiar with the multiple database solution we've offered. So now one project is not tied to one Firebase database. You can go and you can create a second database, another real-time database in that same project, and just use those same config variables to point to one or the other. So that means each one has the same security rules, but the data is completely split. So an accidental rogue remove isn't going to hurt the other one. This allows you to share authentication credentials between prod and staging, but it keeps you a little safer. We also have this support now with Firebase hosting as well. You can host multiple sites on different domains, different subdomains, whatever, from the same Firebase hosting project, and you don't have to worry about them interacting in any way. They're different deploys, it's just setting up your configuration in the right way. So these things are you're beginning to see this trend where we're trying to do more to support developers who have multiple projects and have struggled with that in the past. One last thing I want to talk about that we launched was the management API. This is kind of related here, but if you work in a shop that does a lot of client work, you may find yourself making a lot of Firebase projects, doing things where you're like, all right, every client needs a production and a staging and a dev environment. Our management API is an API that allows you to create new projects. So if you're doing anything like this where you're deploying out your project for other people, the management API allows you to automate a bunch of that. It's not really related, but it's a cool shout out, and it came out in the last year or so. Oh boy. All right, we're chugging along. We got 2 chunks left. I hope my voice holds out. It's cold. I grew up in Wisconsin, but I live in California, so I'm not adjusted to any of this. It's horrible. All right. Monitoring. If you make anything, you should keep an eye on it. Doesn't matter if it's a software package or a child, just make sure you have a general idea what's going on. With generally cloud services, there is an understanding that you are giving up some level of trust. You are giving up some level of insight because inevitably, Firestore does not allow you to view the individual process memory usage of your Firestore instance, but if you were running your own MongoDB cluster, you would be able to. These are the trades we make with monitoring. We're saying, I'm going to pay you a little more money, and you're going to care about that so I don't have to. Now, that's great in essence, But as we scale, we realize that a lot of times we hit edges of cloud providers. There's caveats, there's different things like that. We might just want to monitor what's going on in our application. Even though we trust them to take care of it, we still need alerts. We still need PR people to handle issues when things go down, right? Just because it's not our responsibility, technically, doesn't mean it's not our responsibility to handle the fallout. And that's just kind of the trade-off of doing these cloud-based things. So anytime we talk about monitoring in Firebase or in Google Cloud, we're talking about Stackdriver. Now, Stackdriver is a bunch of different tools. It was a company we bought several years ago, and it's deeply integrated inside of Google Cloud. It's deeply integrated inside of Firebase. And we're only going to touch on a couple of things today because it is such a big product. But if you're ever wondering, how do I know if this is happening in my project? How do I get alerted if this is happening? How do I know if things are safe or whatever? Think about Stackdriver and start there. But I want to keep being practical with this. I want to talk about how most of us debug, which is with console.log, and I want to talk about how we can enhance console.log so with a minimal amount of effort, we can get the most amount of value out of these cloud services. So here's a log inside of Stackdriver logging, which is the part of Stackdriver that prints logs, as you might suspect. And this is the output from that JPEG cool website again. You can see there's a bunch of crap in here. The important part is that there's a few columns you can pay attention to. On the left, we have when did this event occur. In the second column, where we see fulfill cool or request cool, that's the name of the Google Cloud function that created this log. And then next to that, we have an invocation ID. And this is a really cool part. And this is how, in our code, I've changed nothing. I'm just console logging out to my heart's content. I'm saying, you know, it started, it ended, it did this, it did that. And it's just showing up. In a normal, traditional log, this would all be in one gigantic text file. If we're lucky, it might even be tarred up, so we have to unzip it to take a look. But here, if we wanted to, for example, see what was going on with one of our specific invocations, we can click on that execution ID, and it automatically filters down to just that one invocation of the function. So one file upload, one database write, whatever. And here, we can now see the entire life cycle, and we can drop that down, and we can see how long things took, and we can see if it errored and all of that, without changing anything in our code. The only thing different is now we're looking at our logs here instead of looking at our logs in the terminal. And this is much, much better. But that's the beginning, right? That's just a traditional console log that's now prettier and organized, which is great. But we can go a little farther. We can go into Stackdriver error reporting. And again, this is no code change. This is just what you get for going in and turning this on. If your cloud function has an issue, whatever it is, you can see some of these are type errors, which would definitely be fixed by TypeScript. You can go in here and see what the error was. And because it's not just looking at the logs, and it's not you manually trying to parse the logs, this is able to do things like histograms of how often it happened, when was the first time we saw this issue, was it tied to a specific release, what function is it in. It'll even link to the source code of your function, so you can say, oh, okay, this is happening right here. So we get all the benefits of a console log, right? We get the stack trace down there, we get all this other information about where it's happening, but just for free, we get the mapping of when it's happening, and we get alerting. So you can actually go and say, anytime a new error is reported in my code, anything happens in my function that I'm not aware of, shoot me a text, give me an email, whatever, and it'll do that. And it's no code change, no SDK, nothing. It's just part of the managed environment that we should be taking advantage of. But that's still not quite far enough, right? This is still very reactive. It's saying, when something goes wrong, let me know. When I know there's an issue in my logs, let me go look at it. So Stackdriver takes this a little farther, and by a little I mean a lot, into a tool called Stackdriver Monitoring. Now this looks a lot cooler and a lot fancier. It's actually in a separate console, but it's linked to from Google Cloud. And here you can see a huge number of stats that relate to your Firebase project and your Google Cloud project. This is everything from how many REST API writes come through real-time database to how many operations happen on your Firestore, how much bandwidth is hosting using, how many files are being uploaded to cloud storage. All of that data that we don't expose to you in the console because it's very specific and very extra, we throw into here. And this is called Stackdriver monitoring. And when you go into Stackdriver monitoring, you can just go and you can pick random things. So in this situation, I've went up in the top left, I've picked a resource type of a cloud function, and I picked the execution count of the function. And you can see here with those two different colored lines, it's mapping the two functions I have, request cool and fulfill cool, and it lets me see what's the invocation comparison between these two, what's happening more. Now with this service, I know for a fact that request cool is kind of the front end. It's proxies back to the fulfillment service if the data is not in the cache. So I would expect requests to be way higher than fulfillments. And we can look here and we can say, yeah, it is. Requests are, a factor of magnitude higher than the fulfillments. And this is really great to look at right here, but you can take this a step further, and using any of this data, you can build it into a custom dashboard. You can put that dashboard on TV, you can look at it, you can set up alerts and everything like that based off of all this complex data. And it lets you keep an eye on everything going on in your project. To continue with this example, inside of JPEG Cool, I have a cache of every image. As you might expect, sometimes I don't want that cache to live very long, so I go and I manually clear it out. That happens once a day, and by manually I mean, a cron job. It goes and clears it out. So I went and said, all right, if the execution count of that cron job ever falls below 1 a day, that means something's wrong. I don't know what it is. It could be that Google Cloud is having an outage. It could be that I deployed something and the cron is broken, whatever. But I set up this little alert, and I'm just like, hey, anytime my cron job doesn't trigger, just shoot me a text. Let me know about it. And you can see this. It's happened a couple times. There's been incidents where, for whatever reason, we were having some issues. Something didn't trigger this cron job. And so I get a text, which is great, nice and automated. But then because I don't particularly care, it doesn't matter if my cache is busy for a day. It'll just get cleared out in the next cache wipe. So I just leave it. And then Stackdriver will text me again and tell me next time it's ran successfully, and just be like, yo, just so you know, your cron's back on schedule, everything's going good again, and I can just continue. But that's kind of the confidence thing, right? Where I just want to know if something goes wrong. I don't particularly care in this situation, but it's great to know that if something happens where things are outside the thresholds I'm expecting, that I will be told about it, and I don't have to be actively monitoring it. I don't have to be looking at the console logs. I don't have to be looking at Stackdriver error reporting. It'll let me know, and I'll look when I have to. So this is leading into our last section. This is the shortest section, so we should arrive right about on time. And this is everyone's favorite topic, pricing. Just between all of us in this room and the video recording, I'm sure we've all seen blog posts and things like that about people getting unexpected bills from Firebase. This stuff happens. We do our best in those situations to work with the developers and the companies and make sure everyone's happy. But it's still a hassle, right? Even if we refund their money, it's still a hassle for everybody. So it's in everyone's best interest if we think about pricing and we act with the knowledge of everything we've pulled together here to predict pricing and to have a good idea about what things are going to cost. So my first tip here is to make use of those pricing calculators. I'm sure you've seen them on Azure and Google Cloud. They let you go in and they let you say, like, how many millihacker hours am I going to use on the CPU, and how many gigabytes of this am I going to use? And the fundamental problem with all of these pricing calculators is that I don't know what a millihacker hour is. I don't know how much that correlates to a file upload or how much it correlates to my cron job. I can't really speculate about that. Except, what if I had some tool that gave me all this crazy amount of information all stored for me to look at about my project, so I could use that to forecast pricing? And we have that. That's Stackdriver, right? All of that data that we would need to look forward and say, how much would this cost if we had 100x the traffic or 1000x? That's in Stackdriver mixed with these existing pricing calculators. So I think the combination of these two really gives us a new level of insight into pricing, because these things are pretty useless on their own, but once you mix in all that nice information, you get all that insight from monitoring, it gets really, really valuable. One other thing about pricing, this is both in terms of technical pricing and like engineering effort pricing. And this says serverless, but I guess I really mean Firebase as a whole. Firebase is a great tool. and it fits a lot of use cases really well. But one of the situations where things get really expensive is where people try to force apps that don't fit into cloud functions. They don't fit into real-time database. And you know that because as you're developing, you're getting angry and tweeting at us about it. And if you start getting to that point where you feel angry, you should probably reevaluate if it's the right tech stack for you. Most of the time, when we see people having the most success with Firebase, it's with some core of whatever, and then this great surrounding Firebase app, right? It might be the Firebase real-time part, or it might be that we're using Firebase auth and cloud functions, and that's really great, but maybe our business logic's over here. And kind of balancing all that, right? It's not Firebase or anything else. It's kind of Firebase with everything else. And this works, you know, you can invoke everything from Firebase from Azure if you wanted to, or AWS, or whatever. So just finding that balance, you know, and thinking about it and realizing it's not all or nothing. Helps you avoid those situations where you feel like, I'm building on Firebase, I have to make this fit in Firebase, and then it ends up being crazy expensive. And then the last thing about pricing I want to talk about is just kind of to factor in operational costs. Pretty much everything we've talked about today has been trying to make things low effort for you to make things bigger, make them scale well. And Firebase as a platform, just like all these platforms as a service, are always expensive compared to raw metal, or compared to running your own desktop or your Raspberry Pi. But that's because we bring in all these operational support for you, right? The support team is there for you, right? Like DevRel is there for you. And if you reach out to us, I mean, you look at Stack Overflow, for example, you get Firebase engineers on Stack Overflow, right? So just trying to keep in mind that the cost of these services and the cost of building and the likelihood of giving up some control in exchange for us taking care of things is both part of the benefit and part of the disadvantage of using these cloud services. So just thinking about that and being aware of it as you build. But anywho, so that's the Cedar Camp method. And that's basically everything cool about Firebase for Pros from 2018 and 2019 glued together. Just to recap what we talked about clean and strong code, we talked about systematic testing, deployments and rollbacks, dealing with different config and environments, how to monitor things, and then how to use that to figure out good pricing. All the links I shared are here, so if any of those are interesting to you, you should take a picture. I'm almost done. All right, I see all the phones down. Oh, nope, there you go. Good, everyone good? Nope. Yo, I put the slide up like 45 seconds ago. People are like, wait, give me a minute and a half. Now I'll lift the phone. But yeah, so that's my talk. I'm Abe Haskins. You can follow me on Twitter. I'm at AbeIsGreat. I highly recommend it. I tweet great stuff. Otherwise, come talk to me. I'll be around. Thanks for coming. Enjoy Firebase. Talk to you.